Hello everyone, and welcome to Handmade Hero, show where we code a complete game live on stream. When we last left, which was actually a couple of weeks ago because we did some ref term streams, in between, when we last left, we were doing some code for, we wanted to be able to make our collision system, we really want to be able to debug our collision system, in some reasonable way. And I really don't know any way to do that other than by having good diagramming inside the engine itself, meaning some way to draw what's happening, because things like collision are just unfortunately very abstract when you look at the code. It's pretty hard to intuit what is going on by just looking at code. So stepping through a collision routine in a debugger, you're almost never going to see your bugs because they're so geometric in nature, and your brain can't really look at a watch window and extrapolate, oh, this, here are these 3 points, and this is their relationship. Oh, they're coplanar, and that's breaking this thing I was doing. Well, 3 points are always coplanar. 4 points, and they're coplanar, and I was assuming they would actually make a tetrahedron, and that's why my collision detection routine didn't work, and so now I can fix that. Gaining that geometric intuition, most humans can't look at 4 points and tell they're coplanar, right? If all you see is just the numbers. If you show them a picture of 4 points, almost any human can tell that they're coplanar. Even if they're humans who don't know what coplanar is, they can still say, oh, they kind of look like they're all flat, right? So your geometric intuition tends to be the best thing to use for debugging collision detection, and our collision detection is working well enough, but it looked like there were some problems with it, and I wanted to see if we could get some better diagramming in here, just so I can figure out whether or not there are some more bugs in it, or as we see bugs that come up in the course of using it, I want those to not be super mysterious or difficult. And I think the thing we're seeing is like this dude, well, okay, so unfortunately right now I'm not seeing much in the way of the bugs that we were seeing before, so that's a little unnerving. But, I just still want to do it. I thought, yeah, there you go. So there's some weird, like, it was getting kind of stuck in the ground a little bit there. I felt like there were just some things where it felt like there were some bugs. And, it's always hard to know. Oh, like right there, though. So I don't know if those guys have circular collisions or not. They might not, so maybe that's what's going on there. But there's just a bunch of things like that I'm just not sure what's happening. And if I'm not sure what's happening, then I kind of need a way. Oh, so that's. Here's an example, hopefully, right? Well, I mean, yeah, but I still think that should probably work, right? Like when something gets in like that kind of inset, it should be allowed to get out of that, right? And it's having trouble doing that now. And I'm sure it will be allowed to get out of it if we do that, right? But I think it should have still been able to do like a roll off of that. So you can see that I just think there's some bugs in here. They may not be literal bugs in the code. They may be misunderstandings about how we set things up. It could be anything. But without better drawing, there's no way I'm going to know, right? I just won't know what's happening. And so as we see stuff like that happen, I need some way of getting a visual so that I can debug it. And that's really the only thing that I'm talking about at this point. There's also the fact that we would like to add a spatial partition, but that's purely optimization, so I don't care about that right now. What I care about is the ability to do good debugging, right? I also like how our underdamped spring goes nuts. Check that out. That's awesome. This is why you never use an underdamped PDC for controlling things, because it goes crazy like that, right? And that's just that spring getting too powerful, right? As the frame rate goes down, it's a frame rate dependent equation, and you get those kinds of behaviors as the frame rate goes down, or if there's a slow frame or something, right? And it just builds up so much kinetic energy that it can just like shoot over anything, right? Anyway, those are other problems, though, that we'll deal with later. That has nothing to do with collision detection at all. So anyway, that's what we want to do. that's our goal, is just to figure out how to not have that problem, right? Is that a single? Oh, no, that's 2 snakes. I was like, why is there 1 snake that long? It's not. It's 2 snakes. So that's all we really need to do, but it just takes a while to do something like that, right, to put in a system. And we made sort of an idea for it here where we said, all right, suppose that we just have a way of anywhere in the code that we want to, we can just do a bunch of this stuff where we just have like, hey, here's diagrams, right? So you say diagram this, diagram that. And what we want to do here is we want to just be able to say any diagram that we want to make, we can output this way, and then we can look at what it actually drew later, right? So it's basically a debug buffer, is all it is, that fills up with, it fills up with drawing instructions, and it's really exactly the same as our render, like our render command list stuff, right? It just builds up a series of commands that you then do, and the only difference between that renderer and this one is that renderer is meant for like actually driving the GPU. This one is instead meant for convenience. It's just meant for say whatever you kind of want to draw as broadly as possible so it's easy for you. And then we'll draw that for you later by translating those high-level commands into the kinds of things that the renderer can actually produce, like lines, right? So that's all we're trying to do here. And you can kind of see there's a couple of things that seem maybe like they're missing here. Like it probably would be good to have something like this that we didn't put in there, so that you can change what color is the thing that you're drawing. You know what I mean? That's probably a good thing to put in there. And I don't know about maybe line weight. Something like that. And so I don't really know like what are those things we need, but I feel like we probably want some things like that that would just be sticky so that you can say like, here's the thickness, here's the color or whatever, right? That seems fine. And yeah, I don't think we need to belabor the point too much. So when you look at this, you can kind of see, and I'll pop these two additional functions we made down in there too. So, and if you take a look at these, you can kind of see all they're going to be doing is queuing this stuff up, right? There's not a whole lot to it. And so what I'd like to do is just have some way of queuing these that is relatively straightforward. Again, we're not going to do anything fancy. So what I might do is say, well, there are these phases, right? And, it's got like begin and end for phases. And I think, it's got phases and then a begin and end for diagrams. And the diagrams presumably are like, we will want to be able to isolate individual ones. You know what I'm saying? So we'll want to be able, and the other thing is the names that go in here, I don't know if those want to, like, I don't know to what extent we use those too much. So I'm not sure if those should actually be labels like this or not. I don't know. Doesn't really matter. Point being, so what I might do is just say, look, there's like a diagram entry, and the diagram entry is going to have like all of this stuff in it, right? So it's going to have the color and the thickness in it. It's going to have like a, maybe like an A and a B kind of a thing. And it's going to have a type. And in here, we're going to have things like what we said we would draw. So we've got like a sphere, a line, and a box, at least. And then we have some special things that are like these are not actually, I might pop a diagram null in here as well. And then a diagram count. And so in here, I would say, like, okay, there's probably things in here like a phase, a diagram, and a result, which are sort of pseudo. It's weird to have diagram, but that's what we've got. And these are the types of things that can come into this, right? This entry thing. And they just have a bunch of different things that we will stack up. And, I think that's pretty much all we would really need there. There's maybe some parameter stuff like this that we would want. So maybe we have like a, I don't know, parameter like that. And maybe these are from to kind of as well. Or something like that, or I don't know. I mean, there's a couple of different ways you could look at that. I think I'm just going to do A and B, or like, that. 2 points, just because if you want to be Mr. Always, lays things out exactly, and I have to have a type for everything, then what you would do is you'd make a struct for the sphere, a struct for the line, a struct for a box, and you'd put a union in here. To me, that just seems like a waste of time, so rather being Mr. lays everything out, I'm going to be Mrs. doesn't lay everything out and just uses a generic parameter, because I really just don't care. Like, I don't think I'm going to get any additional valuable error checking for that, so I just don't think it matters, right? So that's all I need for the basics. And if I go to the actual file here and I just sort of stick a global in here, and I say like global diagram entries, and I don't know, I may not exactly want to do that. I may say that there's a thing that's like diagram group or whatever, and this is, it's got the color and the thickness that you currently set. And then it's got like a entry count, and then it's got the entries like this, and I don't know how many this has, and no one cares because it's debug anyway. But something like that. And obviously, this stuff can be disabled in debug mode, so we can just say, look, if you're not doing an internal build, then you really don't need any of this stuff. And I guess we already have a thing for it here, right? So we can just disable those by just making all of these things not happen, right? And I don't know why we didn't already do that. Probably because we didn't much care at the time. But all I'm going to do here is I'm just going to take these. Wouldn't it be amazing if, like, anyone at the C++ committee learned to program someday, and then they would know that this is a very common thing that people do? So maybe they should just have a way to define a keyword that is, this thing disappears when this pound define happens, right? Like, all of this nonsense could go away with one tiny language feature, but, we've been waiting 40 years and it hasn't happened, so I'm going to go ahead and guess that it's never gonna. Because that would require someone who actually programs for a living to be on the C++ committee. All right. So, by the way, I don't suppose John is watching. But if John was watching, I would love to know what JAI's solution to this problem is, because I'm guessing he has probably addressed this. Because he does program for a living, and he's probably had to write stupid code like this before, and I'm guessing he probably fixed that. But I don't actually know. He may never have gotten to that. I mean, there's a lot of things to do when you're making a language, so he may not have actually gotten a chance to address something like this before, but I'd be curious to know what he did if he did. I might reorganize that slightly. Okay. To be honest, I guess I'm not sure why there's a diagram end, because you kind of just have these hierarchical phases, right? And so I think maybe that was just a dumb idea. Like, if you had to look at what was going on here, you would probably say something, you would probably not do what I did, right? Like that doesn't really make a lot of sense. You would probably say something more like this, where you say there's a diagram phase, and there's like a phase depth or something. You know what I mean? Where you just say like, oh, there are these phases, and they push. So, you know, and I guess what I could say is, if you were going to do a begin end, then you would just make that be hierarchical. So let's say, let's say that we just have phases, and that the begin and end, you can just make nested diagrams, because otherwise it seems like we've just got extra calls, and those calls don't actually do anything. So, you know, let's just say that is what we're doing, or something. I don't know. So yeah, like, I'm just assuming we dump stuff to this thing, and yeah. So I think what we want is maybe this, right? And each time you do one of these, it can like set the pen or something. So then there would be like this. Where if you didn't actually want to set the pen and you wanted to put text out, you could. So I think that's maybe more like what I'm thinking here. By the way, before I forget, I should check chat to see if anyone knows if John implemented that thing. So I guess nobody knows. All right. So anyway, that all looks fine. Begin, end, color, thickness, sphere, line, box, point, text, out. Yeah. Okay. So I don't really know exactly what I want to do here, but it's probably going to be something like that. Right. And so now these have to be changed a little bit. So it's probably going to look more like this. I think. All right. So let's give that a shot. An implementation shot. And we could too, if we want. We could make this a little bit squinkier. I don't know how squinky we want it to be, but we could make it fairly squinky by actually making this an arena that can just have as much stuff in it as we want. So the other thing I could do is just this. Right. You know, so that it just like threads these things. And you can just have as many as you want. So I don't really remember how this works. And I don't really care. But I'm going to assume that it does things the way I do them now, even though this code is old. So I'm going to assume that we can just do that, right? And that way we can then just say, all right, if enable diagrams, and if, and just to be, maybe that's more what that should be. But that way all of this stuff will compile out automatically, right? And I don't have to rely, on it somehow compiling this out, which it might not, right? So that all seems fine. No real issues there. And then in here where we've got these like phases, that would be what would get pushed on here. And so this will need like a phase depth sort of thing. And I'm not super sure. I want to hold off for just a little bit on the text side of things, because I'm not sure how I want to reference those. There's sort of two ways I can do it, and I'm not sure which one I actually want. There's one that attaches text to the thing by putting it afterwards. That's kind of, you know what? Let's not do that. Let's do it like this. So you say beforehand what the thing is, right? And then you do it and you get the thing. So yeah, that's probably it. So there's like text attached to the thing and blah, blah, blah. And no one cares and whatever, right? So it probably looks more like this, right? You know what I'm saying? So you've got what comes after it in the list. You've got what is the actual like text stuff that's going to be here. I don't remember. I don't really remember how this works when we print stuff out. Yeah, so it's kind of crappy, right? Yeah, it's kind of crappy because we ported it, like basically what we did is we made our own printf. And so it's not designed particularly smart. Right? Like it's not that good. And that's fine. So anyway, let's call it that. And so everyone can have a buffer of text that's associated with whatever it is that they're doing. They can have, whatever this stuff is here, right? And you can set like the parameters or whatever you want for what's going on. Now, whether these are sticky or not is kind of another question. maybe you want the thickness to, or the color to be, maybe you want the color to be sticky, but the thickness not to be, or you certainly don't want the text to be sticky, I don't think. So it's a little bit hard to say what the rules of that would be, and they might be a little counterintuitive, but they just kind of do what you want them to do. I wouldn't be mad about that, but we'll cross that bridge when we come to it. So in each of these cases, all we're really doing is pushing an entry onto the stack. I should say onto the list. It is sort of a stack, but, who cares? And so what we're doing here is, like, each time here, we just have, like, a thing that's, like, push diagram entry or whatever, or append might be the better way to say it. So there's this thing, right? So you grab the global thing that's gonna track these, and the reason that it's global is there's sort of two ways you might do this. You don't really want people to have to pass it through the call chain, and the reason for that is it's a debug system. So it really doesn't make sense to architect around it, because if you were doing that, it's actually having implications for your architecture, and the point is the debug system should end. So normally what you would do is you'd tack it onto the end of a thread context, and each thread would have its own context that does get passed to the chain for actual architecture reasons. But we don't actually do that in Handmade Hero because we don't thread very much. So it's just a vanilla global, whereas it would be in the thread context otherwise. Those are your two choices. There really aren't any other choices. Passing it around would not be a good idea, because passing it around would imply that you've architected for it, and you don't want to architect for debug. Architecting for debug is a very bad idea, because it means that you're making architectural decisions that affect the actual performance of your program so that you can enable debug, and you want the opposite. You want the debug system to be transparent to your architecture so that when it compiles out, there are no implications, right? And that's pretty important. So okay, so for each of these arenas, for each of these entries, I want to ask the arena to give me a new one. So I've got a diagram entry, and I'm just going to say that this arena that I've got here should allow me to do a push struct of one of these diagram entries, right? And that should give me back, what's happening here? Uh-oh. Did I? Oh, it looks like there was I accidentally hit a delete thing or something. Memory arena unknown override specifier. Where did we put this in the list of things? So yeah, this probably needs to be much higher in the list of things, right? Yeah. All right. So, now, the phase thing, I guess each time through this loop is going to look like that, right? So there are the phases. Yeah. And we should have had, I guess we weren't using. I see. We had that with enable diagram still. So I don't think anything in there really needs to be in a block for enable diagrams, right? How about this? So, in theory, I would think that most compilers who aren't completely brain dead, if you put an if 0 in here, then it will compile all of this out, right? I mean, that's what we would expect to have happen. So I feel like that should probably be safe, right? Like that feels like that should probably be uncontroversial. So that way you can put things in blocks that are ifed on whether the system is diagramming or not. And that'll make it very clear to the compiler without needing pound if blocks so that they still get compiled and we know what's going on. And if we change the definition of this, we would get a compile error and stuff, which is what I would prefer, right? So that I think is more what we want here. So yeah. And maybe this is stupid, what I'm doing. I don't know. Right? You know, maybe we need a more succinct way of passing this information. Because I can think of some other ways we could do it. And, you know, there's pros and cons to each. The important thing here is I just want something that works relatively well. And if it's a little verbose, that's okay. As long as I can put everything in that I want. I think it's all right. But, you know, do we maybe want something a little more terse? You know, you can see why pushing that out to a text thing is maybe not as good because it just makes the code too long. So it's something to think about. Right, so, you know, meh, it's not horrible. All right. So yeah, the reason I want that is on switch is because we probably want to be able to turn diagrams on if we so there's enabling diagrams, which means is the code compiled in, but then we may also just want to be able to turn them on and off at runtime in builds when they are compiled in. And so that's really what that is there for. So yeah. This is not this. Yes. So is on begin end color thickness text sphere line box point overlay. Okay. So now we just need to buffer these up as they go. And so I guess really what's going to happen here is each time we do a begin, we need to push on one of these. And, so this is going to be a clear, right? So I think we clear by default, if I remember correctly. We can double check that. But I'm pretty sure like the default thing to do when you do a push size is to clear. So that will just clear it, and then all we have to do is set the other pieces. Now, probably everyone's going to pass one of these, so we might as well just say that gets set for you. And then the other things in here probably can get set based on what the thing is that's actually being called. Some of them probably can get set. So like the value and the thickness, right? The color and the thickness. The color and the thickness can just get set from the group because those are going to be like sticky, right? This and this. And the same thing would be probably for the text, right? So you would probably expect to see something like this. Yeah. And since you can kind of see where that's going, I feel like you probably want this. Like maybe attributes, right? And the attributes for each thing just are in here. You know what I'm saying? That way we can have attributes on the group that just get applied each time. And furthermore, we can do this. So that we have a default set and a current set. Oops. Right. So that way we can add one more command, which is like stick. So if you want to set a permanent thing, you can. So after you set like color or thickness or text or any of those things, if you want those to apply to everything, for the rest of the thing that you're doing, then you can just call stick and it will apply those settings, right? So, and all that is it just takes the global attrib group where these things are being tracked and says that the default attrib equals whatever the current attrib is, right? That's it. These are now, really straightforward, the color and the thickness, because they're very simple. They just set whatever the current attribute is, they just set it. And the text one is more complicated, partially because we don't really have an arena-based push. of these things. At least I don't think we do, and maybe we actually secretly do, and we just forgot about it. You can see I even have a to-do, so it's like we knew that this was lousy. This was the thing I was actually talking about, right? So we knew that kind of sucked, but we just haven't ever had a chance to go unsuck it, right? Which is fine. So here's, I'm going to leave the text one for now because, like I said, that one requires a little bit more finesse. Let's just do the rest of these. So append diagram entry now, where we just have, you know, I mean, you know what we're doing here, right? It's just, it's literally just stacking these, right? So what we need to do here is when we push these on, we also need to set the like first and last pointers. So you got these first and last pointers here. That's the chain of things that we've seen. And you know, so that's just going to be like, this sort of thing, right? Anyway, doesn't matter. Point being, we're just chaining these things on, and each time that we see a new one, we want to add it to the end of the list. And so the reason that we can't just keep a push-down version of it is when we go to actually draw these, we want to draw them in order. Like the person who was recording them wants to draw them in the order that they were seen, because we're trying to step through the run of the program in the diagram by diagram, and you don't want to see like the last diagram first or something, right? So what we want to do here is we want to actually go through each of these and say, okay, every time the last entry needs to point to whatever the current one we just made is. If there is a last entry already, then we just want to set the next pointer to the entry that we're talking about. Whereas if we haven't done the first one yet, then it's going to set the first one. Right? So it's, again, pretty straightforward. That just makes a linked list of these things, and that's all it does, right? So that way, we can now implement all of these really easily. There's really nothing to it. So we're just going to do this append diagram entry, and each time we're just going to pass whatever the type of the thing is that we were actually going to draw. So each of these will look like that. And the only thing that they're going to do is say like, hey, it's a sphere or whatever, right? And we just say, well, there's a center, and a radius, right? And that's it. And then for this one, well, it's a line. So there's the, you know, from and the to. There's, you know, a box. And a point. And then we didn't really do overlay, but we need one. And that's just if you want to if you're just trying to display some text that doesn't really go anywhere on the diagram, right? So it's just text, right? It'll just overlay it on top of the diagram in like a HUD or something. Now we've got one more thing that needs to be recorded. This does not. That's not a thing anymore. We got one more thing that needs to be recorded, and that is the phase, right? So we need markers each time we have a phase, and the value that that is in the phase. I don't know if this, so this is really just, it may not make any sense to actually do this. It may make more sense to just say, look, there's 2 points, and this stuff will just have a phase begin, phase end. There'll just be a begin and an end. And that'll just get tracked when you're drawing it. That probably makes more sense because there's no need for that value. So it's probably, and then you just actually have that stack depth maintained here. So probably this is better. And these don't actually have any parameters, so they can just kind of just be ignored. The return value, because you're not going to do anything with it, right? So that does a complete recording of everything we wanted to draw, right? And as you can see, it's almost no code, right? So it's pretty cheap to make one of these things, and that's it, right? The only thing we haven't done is the text output, and then we can just move to the drawing phase where we just convert these things to something you can actually put on the screen, which will be a little more work because it's doing more than merely recording what the person wanted to do. But as you can see, if you write this sensibly, there's not a lot to it. It's really straightforward to the recording part. It's pretty basic, right? Now, one thing we might want to do is when you begin a diagram, we should probably clear out like so the only thing I'm thinking here is like when you actually do one of these diagrams, we probably want to be able to keep track of the state, right? So I wonder if it wouldn't maybe make more sense to just actually just record that state and have the render side track it. That's a good question. Yeah, I think I might just do that. So, because I think we could just say, well, let's just make it entirely run at that time. So you could do this. So either you specify points to draw or you specify attributes that you're changing. That makes a lot of sense to me. So maybe let's just do that. Yeah, I think I like that better. And then you just have them up here. That seems good. And these now actually have an entry. So like changing this stuff just has an entry. Like so. And that seems okay. That seems better to me. I think I like that better. So this doesn't have to happen, which makes that more efficient. And the structs are smaller, so that just seems like a better choice pretty much across the board. Don't ask me why that's not a pointer. And why didn't it complain about this one? This doesn't need a return value because it doesn't do anything. Okay. So last but not least is text. It's actually very simple what's happening there. Also, because this seems like it's only ever going to be just in the interest of being slightly more efficient, we can also put text, I think, in here because we know that you don't really need. I don't think you ever need to specify more than that. So the diagram attributes can just be a thing that exists in here because they're the ones that might be sticky, and we'll play that a little bit in a second. But then the text, that way, this whole thing is only ever going to take the size of this. So 6 floats. 6 floats, great adventure. And all we need to do here now is set this text buffer to something. Right. Now, we know that we can do a... so if we go to the format string side of things, we know that we can do this. So we know that we can do an arglist format, and we can pass it to this thing, and off we go. And the problem that we have, right, is we don't know what to do with this. So we don't know what to do with this dest size dest here. These are now known, right? It's what came in as the printf. But these we don't actually know what they are because we don't have any buffer to put these things in. But we have an arena, right? So what we should be able to do with the arena, and I don't know to what extent we support this, because like I said, it looked kind of crappy, and that's fine. But it's just, it is what it is. When we're doing the push size on here, we've got this sort of stuff where you can do like a, you can do like begin and end where you can check like how much memory you used, and you can rewind and stuff like that. That's what this end temporary memory does. You can see it rewind and reset the used part here. And the stupid thing about this is what you would normally want to do here is you just push on like a large chunk, like 4096. You do the printf into it, and then you just rewind the pointer back to however much it actually took, right? That's what this would normally do. But we don't really have a way to do that, right? So I'm not going to do that because I don't really want to muck with that part of the code. There's no point in doing that. This is just a debug system. So if we just make a thing that's like, okay, the global has some format buffer, and we'll just put it into the format buffer, right? This is an inefficient and stupid way to do it, but we don't care. So at the moment, we'll just do it that way instead. And the way that will look is, we'll take this diagram group. And we're going to say, however big this is, you can put it in there. And then you can tell us how big it actually will be, right? And we'll do like a push copy. You know what I'm saying? So a push copy is just saying I'm going to give you a block of memory and you're going to, push it on in there. So if we do a push copy, we push an arena, a size, a source, and then the params, we want like no clear, right? Because it would be dumb to push a copy something there'd be no reason to clear it first, right? So we're going to push on this result, and we're going to push on this source, and we're going to push it onto this arena. That will push the copy on, and then we just have to do, like, is there a make buffer or a wrap? What does this do? Wrap bundle string. So then we can just say to bundle that into a buffer, and now we've got the string, right? So not fabulous because this is just inefficient for no reason. But, so you can say here if you wanted to. Right, so that's fine. And now we have a complete recording, so all we really need is a function that draws this, right? And if we, we just need some function that will dump this down to the render buffer as we go. And the other thing the thing about it too is, like, we've got all this other drawing code right now that's in there for no reason that we could also, like, so there's drawing code that is in the actual collision detector that's drawing those little boxes. That should all get moved to this code as well, right? Obviously. Because we don't need that sort of like hacky drawing code now that we actually have a way to record things into a debug buffer and then play them back. That would obviously be, right, what you would do. Now, there's a lot of stuff that we can do here, and we'll kind of get into that probably next weekend. The things that we can do here. So one of the reasons I predicated the diagram stuff, you can see with this like diagram is on call, is we can make it so that this is completely dynamic, where like as you step through diagrams, it'll just only turn on the ones that you actually are looking at. That will help keep the speed high, so that people aren't syncing like hundreds of thousands of these diagram calls every frame, only for us never to actually need any of them because we're not looking at them. So that way, that can always return 0 except for the diagram you're actually looking at, right? So that would keep it to just diagram begin and end are getting called to like say what diagrams are available, but all of the actual information in the diagram just would never actually happen unless you specifically ask to view that diagram. So that's, just to give you an idea of like where that should be going. It should be something like that. So after you do all of this, there should at some point here now be a call that's like, convert, or something like diagram, convert the diagrams to, or render diagrams, I guess. Render diagrams, that kind of thing. And that's going to take like the render group. And it's going to take whatever the diagrams are from the diagram set, and it's just going to dump them out, right? It's just going to dump them out. So, yeah. That's basically what we want. Ugh, I'm tired. I guess I didn't get enough sleep last night, which is unfortunate. So, we would do that, and I'm assuming that, like, the place we would put that is, like, in here somewhere, right? Because we've got this stuff that, like, when you're running... What is this complaining about? I have no idea what this is complaining about at the moment. Hold on. Oh. We don't... That's right. I always do it this way on Handmade Hero. I don't build twice for whatever reason. Probably should. So that should crash again here, hopefully. Yeah. So I don't know what that's about. It doesn't like this debug record allocation, the call to the debug system here. But I'm not actually sure why. That all looks fine. And that looks fine. But this... apparently it doesn't like. Our debug system is so terrible. At some point we should just rip it out and replace it with something better. But I can't say I see what the immediate thing is writing location 0. It's something in that actual macro. Like trying to get that event, right? Because it's actually in the debug record allocation call that, like, it's not able to get one of these events or something. My assumption would be that is just because this is getting called so many times that we're actually running out of these events. You know what I mean? That'd be my guess. Which is annoying, to say the least. But I guess we just don't do enough small allocations normally to actually make that be a problem for this particular system, right? Meh. So I'm not sure what to do about that, other than to say that that particular thing where we record those allocations is not particularly useful. Like, what that was used for is... So let me disable this and we'll go through it. So what that was used for was... oops, it's still running. What that was used for was a pretty stupid thing. I think it was just something someone asked for, so we did it. But I don't actually think it's particularly useful. I don't know that we almost never use it. At least I don't remember ever using it. But wait, did I not just... That was funny. I set it to 9. No, 9 does not disable Append if, in case anyone was wondering. So we've got this thing that's like this. And you can view, like, how your memory is laid out. You know what I'm saying? So this is all the memory in the system. And you can see, like, who allocated it or whatever, right? So that's all that's doing. it doesn't do anything else. It's just this, right? Yeah. So you can kind of see like where all your memory is, or whatever. And I don't know. No one cares. But that's just what it is, right? And being able to see this level of granularity is what causes the problem, because if you do tons of little allocations in there, the debug system is trying to store all of those and eventually just runs out of space to store them because we don't allocate that much space to the debug system itself. And that's basically it. I'm not sure there's really anything else to it. And a lot of that's just because the debug system is terrible, right? There's so many reasons why the debug system is terrible, it's hard to describe how many reasons there are. It's just bad in a lot of ways. And it's just one of the things it's one of the casualties of the way Handmade Hero is developed, not being able to spend like weeks at a time on something where you concentrate on it for several hours every day. It's pretty hard to do complex systems well if you're trying new stuff. And so in this particular case, I don't know why I can't jump to that. Global, yeah. In this particular case, right, it just ends up not being very good. And, it definitely costs us something, because not having a good debug system and having to deal with crap like this is not what you want. But, there's only so much you can do about that. So the global debug table, I don't actually even know how we were doing that. We were using that so we could use that weird counter trick, which I don't really know how valuable that even is. But so I guess what I really probably want to look at is this. Yeah. So you can see here, like, hey, it's this thing with like a tremendous number of these like debug events. There's just tons of them. And I assume what's happening there is it's just blowing out like whatever that number is. It's too many, right? So, you can up the number. I don't know. How big are these things? What a strange thing. So it's got a U64. So this is like 8, 8, and then just an unbalanced with a pad, 8, 8. So that's like, a 32. And then whatever the heck this thing is, that's going to be the biggest, probably, is a Rec 3. So that's 9 floats, right? So, like, looking at the layout of this, it's like, it's like 9 floats plus, 32, 68. Fantastic number. Okay. So 68 of these, I don't know. This is just stupid. The way this is done. But so 68 is fine. So we got 16 times 65536 times 2 times 68. So it's pretty huge, right? It's a 142 megabyte buffer for debug. That said, it's a debug buffer, so you can pretty much make it as large as you want, and no one's going to care because it doesn't actually ship with the game. So I suppose there's that. If we were to make this bigger, so it takes half a meg, does anyone care? And does that fix our problem? If so, that's probably what we should do. But we'll see. Yeah. So basically, if we just let it have more, then it's fine. So that's okay with me. If we take a look at the arenas now, do we see that stuff happening? Oh, wait, no. We didn't turn back on the diagram. So we don't know if that, yeah. We don't know that that actually helped. Oh! False alarm. That may not actually be necessary yet. The reason that may not be necessary is we're not clearing these, right? We haven't called render diagrams yet, right? So we haven't actually called any of this stuff. So it'll just keep piling up forever. So that, yeah, that probably is the problem. So we're okay. No need to panic. I just forgot we hadn't actually finished this stuff yet, so it would just grow forever, right? So all we really have to do here probably is clear this arena, right? And I'm gonna go ahead and pull out this as a local, just so I don't have to keep typing it. So if we go ahead and say, look, clear that arena, get rid of all that. How does that work in the debug system, though? Yeah, so, now that I think about it, I maybe, that may be false alarm, though. Maybe it is a problem, because the debug thing will get cleared every time, because that always gets cleared. So, yeah. So that does seem weird. Also, debug arena suppress does seem like we could use that as well. So we could get rid of this arena from the system so that wouldn't be a problem, right? Yeah, I don't know. Anyway, when we look at this here, it looks like it records the block freeze as well, so the clear would work. But those things all I thought just got freed anyway. So I don't know. I'm gonna go ahead and do this part, but I do think we may have some stuff to worry about anyway. So let's suppose we do a clear on this, so that we do clear out the group every time, like so. And so every time in Handmade, update and render or whatever, not update and render editor. Although maybe that does make sense. I don't know. Maybe that is where it should be. But update and render, I'm thinking more like just update and render regular, like in handmade.cpp, right? So in this game update and render, right? When we go through here, I'm just wondering, like, maybe this happens after we do whatever this UI nonsense is here, right? So we do that, and then we clear the diagrams. And that probably has to be something that is going to go through this system. Maybe that. Right, so that it doesn't cause a problem. So that'll be diagram reset. That'll be called every frame. And so now at least we know those will get rid of any things that are, in the way. So if I go ahead and make that a 1, so now the diagram code is enabled. and I run it. Now I want to see, like, is this actually a problem with too many of these? I want to know, right? So looking at the global debug table, okay, I'm pretty sure it's not 0. That seems unlikely. Let's try that again, folks. So I suppose what I don't know is how is that event array index thing doing what it's doing? So it's just a 64-bit value that's split into 2 halves, right? So top one looks irrelevant. So it is just an overflow, right? That's all it is. And so now I just don't know. Like, is that actually expected? And maybe it is. I don't know. So what I'd like to do here is just say, well, let's find out. Let's boost that number and see what happens. Just so I can have some perspective on whether it actually is an unbounded problem, or whether it's just a yeah. So it really feels, well, that's a little bit odd though, because that number is the same number. Oh, but that's just what we put in there. So here's our new one, right? So it really feels unbounded, right? It feels like we're doing something where it's not really that we don't have enough. It feels kind of unbounded, and I'm not sure why. You know what I'm saying? So let's see if we can figure out what's going on there, if there's some kind of thing that I screwed up. Or maybe it really is just that many diagrams. You know what I mean? So I guess if you look at what's happening here, I guess it really could just be that many diagrams, because if you look, it's any time you call move entity, it's doing the n squared check, because we don't have the spatial partition, right? So if it's an n squared thing, yeah, that probably just will blow out the total diagram. I mean, you wouldn't want to record that many of them, right? So that does seem like just flat out a problem. And I'm not sure. Like, maybe the right thing to do here is to limit this to a particular entity, You know what I mean? Like, if we just want to see particular entities, we can have some way of restricting it. Because, I'm going to want to use these diagrams all over the place, so I don't really want... Like, I can't afford to have them be something that's producing billions and billions of things. So I need a way of scoping them down more. So maybe we do something like... How would we do this? So we basically need some filter here, and I'm guessing that we just need like entity filters. So I'm thinking that probably what we want is like sort of this sort of thing. So like whoever's trying to do like pushes has to check to see what's up, right? And then we will just return 0 when the filter says that the diagram is not necessary at that time. And so here we can just say like, okay, if we want to actually do the thing, otherwise return 0. And we can just turn it off that way. You know what I mean? And so now we just need a way of articulating what the filter actually is. Right? But otherwise we should be fine. So now if I go ahead and restore to a optimized build, like so. Now what we need is just a way of like, spot turning it on. So, like... I guess we just want this thing to just do... I really don't know. But my hunch is we just use some kind of like an ID. So, something like an entity ID, like we have. We could just say something like, in the diagrams, we pass a filter. So you say like, I'm gonna begin like, you pass a filter, and everything from then on, if it doesn't match the filter, right or whatever, it doesn't pass. I don't know. So you would do like... you pass some value here, and there's like a set that someone can call. And then each time through when we do these, it's like, okay, we know we're going to be doing a bunch of diagramming. And so the thing is like, well, the diagram filter here is going to be like, you know, two, and there should probably be like multiple pieces to this. Like this thing should probably take like a char star or something, or like a void star that's like a type string or something, and then the value. So it would be like, okay, you know, it's this function, and just to like disambiguate which one you're doing. Although I guess that's probably not that necessary, because you can just pick those out. So let's ignore that. So we'll just say, look, there's the entity. We're going to pass the ID as the filter, and that will give us a way of only outputting the diagrams we actually care about at any particular time, hopefully. And we'll go from there. That seems fine. And the way this would work is now we like have some notion of like, did you pass the filter? So in here, we've got a filter passed variable, and like the filter itself. And so in here you would say set filter just does a global diagram group filter equals value. And in here you would just have global diagram group filter passed equals like whatever this thing is that you're getting. If it equals whatever the last thing was set as the filter, then you can draw, right? So at that point, this just works, and this is now just if the diagramming is on, right? And I think then we're fine. So now the diagramming is actually live, and you can run it, and in theory, we won't have that problem with too many diagrams. And now you should be able to sync your diagrams just fine by turning on the filter for a particular entity, right? And then what we can do is just next time, we'll find a free F key. There are not many. Oh, we've already got one, right? So really all we need to do is go into this collision recorder thing, change this to diagramming, and then it will step us through, right? So that's what we'll do next week, is tie that up to it, and then we should have some diagrams. Whether we'll find anything with them, I don't know, but hopefully they'll make it clear what's going on. The other nice thing we could do there is like, we can finally shut off some of this other stuff. So like if we go back into world mode, we don't have to keep drawing stupid colliders and stuff. There we go. So we don't have to draw like this stuff anymore, because we can now put that into the diagram so that we only see the colliders that we actually care about that are like in the region we're looking in and all those sorts of things. So that would clean things up nicely so that when we're normally running, we see the actual thing correctly, which is much better. just so we have some idea of what the heck is going on. And then we'll just make it so that as we get, closer to things, it draws their collision volumes in using the actual diagramming, right? And then we should be able to see, we can set the diagramming to show the glove, and then when we get those things where it sticks on the corner, and we don't think it should, because the sphere roll-off should have solved that, right? Or that was the hope anyway. We can see why. And that's really what we want here. You know what I mean? All right. So that's it, folks. Any questions about what we just did? It all looks okay. I think it's... So the only thing that I would say about it is, one thing I would probably do if this was something I was programming in myself with a lot more time, I would say you probably want to make it easier to specify the diagrams. So I might make it so you can just throw those up on there. If that makes sense. Do you know about WebView 2? That doesn't sound on topic, Synthusiast. Well, WebView 2 just kind of sounds like, Electron for Windows, right? I mean, that doesn't seem weird. It's just, hey, you wanted to put a website content thing into your, into your app. That, I mean, we already have that, but I guess this is Microsoft's version of it, right? What's the sphere roll-off? So what I was trying to say there was just that so one of the things that we added to the collision system was spheres, and they don't seem to work right, because you would expect sphere colliders to be able to roll off the side of when they hit, the collision normal is going to be pointing towards the center of the sphere, which means that if you hit anywhere to the side of the center of the sphere, it should be able to roll around the corner instead of getting stuck. And, that needs to get debugged, because it doesn't look like it's working. You made it about rewinding a memory arena. Does a rewind free the allocation? It doesn't have to. The important part about that particular to-do was I was just trying to note that what we don't want to do is we don't want to push some space on, use it for a printf buffer, and then orphan all the space that wasn't used, because that's just a tremendous waste, especially when you're doing potentially a lot of these like we would be. So if you put on 1024 because you want to support large string printfs, and most of your strings are 16 characters or something, you're orphaning basically 1,000 bytes in the arena that you can't use for anything. They just got wasted on that frame, right? And yeah, it all gets cleared at the end, so maybe you don't care, but it's still a tremendous amount of wasted memory paging that doesn't have to happen. And so the way smarter thing to do is when you do a printf like that, you printf into the buffer and you then record the amount you actually used. And it's very simple. It's a really simple addition to arenas that, you should do. Shouldn't we add spatial partitioning for collision and such at this point? Not till it's debugged. So I don't want to. So typically, when you're talking about spatial partitioning for things, the best time to do spatial partitioning is after you're done with the algorithm. Because until you're done with the algorithm and until you have it completely debugged and you know that it's what you want, you may end up making if you do it before then, you may end up making a spatial partition that doesn't answer the questions you actually needed. Because you add a question or you change how a question is asked when you modify the routine. So I would highly recommend not adding a spatial partition until after you're done with the actual routine, because then you know what you need, whereas until you're done, you don't. You mentioned you were doing memory arenas differently now. What are you doing differently? So nowadays, I lean on the 64-bit stuff more. So a lot of times I'll set up arenas. If they're growable arenas, they grow in linear order. They don't use chunks as much, right? Because you don't really need chunks as much when you have a full 64-bit address space. You can kind of just like grow linearly pretty much all the time. It's pretty rare to need anything else. So, you know, you do it a little bit differently. In the early days, you're mentioning that Story's got enough attraction. You could possibly look into networking. What are your chances now? No, if you want networking, you're going to have to do Starcode Galaxy. Starcode Galaxy covers networking. Handmade Hero will not. So, you know, when this comes out, you'll get your networking, and there's a lot of it. But Handmade Heroes, no networking. Why do you forward declare the diagram function of the header file? I thought you did the Unity build system, so you didn't need that kind of thing unless the pound include order requires it. Well, there's a couple of reasons to or not to do it, right? Yeah, one is for the pound include order. The other is just for my own organization. So when I do, typically, when I do something where I have to do this crap because of C++, I typically also put the non-pound defined versions up here. And that's just so I can see them and make sure that I remember to do them both, right? So you don't really need them. You probably, well, I don't know. Let me just see. I'm not sure what our... There we go. You probably don't need them, so you probably could do this, right? And it still works. But typically typically what happens is I end up putting them in there when I'm trying to keep them lined up, right? Do you know any particular reason why MSVC would optimize a piece of code better with /OX instead of /O2? Can you be more specific? I don't even remember what I hate remembering things like command line switches and stuff. So I don't even remember what that is. /OX is favor speed. So you're asking why is /O2 and /OX, you're expecting them to be the same because they're both favor speed? Or, and you're not seeing that? Or something? So I can give a meta answer because obviously I have no idea because I don't write the compiler. But what I would do is I would go to here, right? Nope, not that. Did I type that wrong? There we go. I guess I typed it wrong. So I would go to here, and I would put in your code that you're talking about, whatever it is, right? And then I would just set this up to look at both of them. So I'd add 2 compilers. I'd add Microsoft's, increasingly terrible compiler as they release new versions of it. The latest version of Microsoft Visual C compiler is one of the worst I've ever experienced. In the in the 30-year history of me having used this compiler, is that right? So like 92, so 10, 10, 10. Yeah. In the 30-year history of using the compiler, their latest one is probably one of the worst I've ever experienced. It's absolutely horrific. It gets worse with every version, and this latest version is just insane. Absolutely terrible. So I'm assuming that everyone will eventually switch to Clang because they have to, because Microsoft continues to make their compiler so bad that I don't think anyone could use it eventually. But, that's where we're at. So, I would type in whatever the thing is that you're trying to do here. And then what I would do is, oops, I forgot this needs to return something. I would look and see if you can narrow down what the actual difference is between the assembly language between these two, right? And so that is what I would do, because then you can find out like what is the actual diff, that it, what is it actually changing that is making the speed difference, right? And then you can investigate that. But I would start by trying to find the actual difference. And you can pick your exact version of MSVC if you're not using the latest one. But that's where I would start. What do you mean by grow linearly? So what I mean is that in a 64-bit address space, you can just pick very sparse starting points for your arenas so that they have as much room to grow as they want, right? That's all I mean. Yeah, and Botondar, my answer is the same, right? It doesn't matter which one of these produces more. Regardless of which one produces the faster code, you want to find out by doing this. And there's multiple reasons for that. One is you might want to report a bug. I mean, we've seen what happens when you report a bug to Microsoft, so maybe don't do that. But you will be able to see what's going wrong. And then when you see what's going wrong, you can try to change your routines to work around it, right? Because you have to remember that when you're asking the compiler to optimize something, what really is happening is the compiler is applying a bunch of heuristics about what it thinks is going to happen to your code. But it never actually tests them, right? So the compiler never like compiles and runs the code to see whether it's faster. It's just guessing that if it applies the transformations that it thinks are faster, that it will get faster, right? That's what it's doing. And so when you ask it for maximum optimizations, it's simply what it's going to apply are the optimizations that it generally thinks are the best. But there's no guarantee that that code will actually be better. That code may actually be worse for all we know, right? It may be worse than debug in some really rare cases, because the compiler never checks, right? The compiler never checks to see whether the code actually got faster. It's never running the code. Only you are running the code, and you're the one who knows that it got slower. So what you have to do is when you see a case where two different flags produce different speeds and it's unclear why, you're like, that doesn't make sense because this one is supposed to be faster. The only thing you could do is go look. You just have to go look. And then when you find out what the problem is, you can try to work around it by changing your C code or hand optimizing that part that got slower so that the compiler doesn't have to figure it out, right? When you're doing code optimization through a compiler, you have to do a bunch of that stupid dance where you go in there and you you make little changes to your C code to try and nudge the compiler towards the right thing to do, right? Would it be possible to render all of the unfiltered n-squared diagrams if the number of debug events was huge, or are there just way too many diagrams for that? One of the problems, so there's a difference between what's possible and what's feasible, right? So it's probably possible to render all the diagrams, but the debug system is not set up to be super optimal because it's a debug system, right? And so the problem that you get is that you don't actually want to spend a bunch of time optimizing the throughput of your debug diagrams, right? So what's feasible to do and what's possible to do are very different in this case, because if we don't want to spend a bunch of time optimizing the throughput of our debug system so that we can draw billions of diagrams, which might be very possible on today's hardware, it's just not feasible for us because we're trying to do other stuff. We don't want to spend all our time on a debug diagram system. If we did, we might be optimizing it for that kind of throughput, right? And for the record, that would be a cool project, right? So if someone wanted to do a really highly optimized, very awesome debug system that you could use in your games or whatever, that's a great tool, right? So it's not so much that you don't want to make a super highly optimized debug system, it's just that that's its own project, right? And so if you're not doing that project, then it doesn't make much sense to do it. I think that's all the questions. What's used to build on Linux? I don't know what you mean. What do I use to build on Linux? I just use a compiler. I usually use Clang. Sometimes I use GCC if that's the thing that's installed. Do you know that Sean Barrett is writing a C compiler? Are you going to use it? I mean, I don't really have any use for a C compiler, so I program in C++. I don't use a lot of C++ features, but I use, operator overloading and stuff like that, so a C compiler doesn't really help me. Oh, any build system or just a .sh file. Same exact thing as I do on Windows. It's just a .sh file that just says Clang and then the C file and a bunch of switches. That's the entire build, right? All right. Thank you, everyone, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you, as always. If you want to follow the series, you can always pre-order the game on handmadehero.org, and it comes with the source code. I will be back here next week to do this actual, basically we did all the work for like queuing up our diagrams, and so now we need something that will actually draw them, right? And so we'll just make our little like drawing loop, and then we should have some diagrams. The hope is that will make it pretty easy for us to figure out what goes on with things, like spheres, like whatever, but I don't actually know, so it'll be more of a question of like, at that point it'll become a little bit of a discovery process where we start drawing things, and hopefully those drawings will help us discover some of the problems that might be lurking in the collision code that's hard to find without drawing. That's it. I will see you next week. Until then, have fun programming, everyone, and I will see you on the internet. I don't suppose